We've got a straight line graph here, so I'm thinking y equals mx plus c, but we don't have y, we've got log base 10 of n is equal to m. We don't have x, we've got t plus c, the y-intercept, which we know is 3.08. Now I just need to work out what the gradient is to replace this m here. I know we can find the gradient by doing the change in the y. So that's 3.85 minus 3.08 divided by the change in the x. So that's 5 minus 0. And if we do that, we get 0.154. So that's our gradient. So that's part A of this question done. We found an equation for the line. Right, part B says we now need to work out the value of A and B, which were given to us in the original equation, n equals ab to the power t. So I'm going to take my equation for the straight line, so the log to the base 10 of n is equal to 0.154t plus 3.08. I'm going to take that and I'm going to do 10 to the power on both sides. So 10 to the power on the left-hand side and 10 to the power on the right-hand side. The reason why I'm doing that is on the left-hand side now I'll have 10 to the power of log base 10. They're going to cancel out and just leave me with the n at the front, which was what I needed. Now the right-hand side is much more complicated. We need to be really careful with this. I'm going to have 10 to the power of the 0.154t. Now, I can see here that the powers are being added, which means that the bases are going to be multiplied. So just using index laws to split that up. Really important we have a multiply here. If the powers are being added, the bases are being multiplied. So what we can do now is actually work out what is 10 to the power of 3.08. So I'm going to put that in my calculator. 10 to the power of 3.08. I get 1,202 to 3 significant figures. That's going to be 1,200. Next, I'm going to think about this 10 to the power of 1.54t. Sorry, 0.145t. Now I can think of that as being 10 to the power of 0.145 all to the power t. Because I know if I were to multiply these powers together, I'd get this. And that's useful because I can now put the 10 to the power of the 0.154, I can put that into my calculator. So 10 to the power of 0.154 is 1.42 to 1.43 to 3 significant figures. And that's the power t. So, therefore, my n, I can swap these two terms around just to write it with the number at the front and the algebraic term at the back. 1,200 is the A and 1.43 is the B. And that's part B of the question done. Part C says that when T is capital T, the number of subscribers is 500,000. According to the model, so according to my equation, we need to find the value of T when N is 500,000. So if I divide by 1,200, so 500,000 divided by 1,200, we get 416.6. Now I'm going to take logarithms of both sides so that I can bring the T down. And divide both sides by the log 1.43. And we get 16.865. So I'm going to round that to be 17 years.